Section 6.4 is solving compound inequalities. So in a compound inequality we have two types. The first are called AND inequalities. So let's get this written down and then we'll talk about it. A compound inequality containing AND is true only if both inequalities are true. The graph of a compound inequality containing AND is the intersection of the graphs of the two inequalities. So pause and copy that down. So when we say that the two things are true, in other words, you are going to be able to go to the movies and you're going to be able to get ice cream. So both of those things are going to be true. Unlike an OR statement, which we'll talk about in a minute, where you have to choose one or the other. So an AND inequality. A statement like this, -5 is less than x minus 4 less than 2. We read it this way. We read the middle first. X minus 4 is greater than -5 and it has to be less than 2. It has to be, this statement has to be both greater than -5 and less than 2. So there are two ways to go about solving this. We can write this as a two-part statement. We can say x minus 4 is greater than -5 and x minus 4 is less than 2. Solving this, we get x is greater than -1 and x is less than 6. If I graph x is greater than -1, it would be the graph going that way. If I graph, and I'm going to do this underneath, if I graph x is less than 6, it would go that way. Now you see that these two statements have a section where they overlap. X can be greater than 1 all the way up here, but on the right hand side here it's no longer less than 6. And x can be less than 6 all the way down here, but after we get past our -1 point, fix that a little bit, it's no longer greater than -1. So the only area that both of those statements are true is in between -1 and 6. The other way to write this is to keep it exactly the way it is, and this is the way I like to look at it. So if I add 4 to what is really all three sides, I've got two things happening at once. So the right hand side I'm going to add 4 over here, the left hand side I'm going to add 4 over here. So I'm going to get -1 is less than x, which is less than 6. We can see now that the x has to be between -1 and 6. So I can go straight to my graph, plot my endpoints, and put my solution in between. Okay, so when the expression is written as one big statement where the x variable term is in between two numbers, that means that that solution has to be both greater than -1 and less than 6. Now let's look at an OR inequality. A compound inequality containing OR is true if either of the inequalities are true. Doesn't have to be both, just one or the other. The graph of a compound inequality containing OR is the union of the graphs. That means we're going to include everything, not just the overlapping part. So write that down. Okay, OR inequalities have to be written as two separate statements. They cannot be written as one united statement because it's two separate pieces. Not both together, but one or the other. So let's solve the one on the left here. -3x is less than 15. Since I'm dividing by a negative, don't forget to switch your inequality symbol. This one, 7x is greater than 21. Divide by 7, and I get x, This should have been less than, I'm sorry. Go back and nope. This one should have been greater than to start with. My apologies. So fix that. Greater than. Nope. Greater than and switch. Okay, I'm sorry. Let's go back. Let me start again for you. So negative 3x plus 4 is greater than 19. Subtract the 4. Negative 3x is greater than 15. Divide by a negative. I flip my inequality symbol. X is less than negative 5. Over here we have x is greater than 3. So again, if I graph this first one, 0, negative 5, less than negative 5 is over here. If I graph the second one, and again I'm going to put it underneath so we can compare them, greater than 3. Now in this case there is no place where x can be both less than negative 5 and greater than 3. But if I use my OR statement that x can be less than negative 5 or greater than 3, this is my solution now, because x can be either of these things. Doesn't have to fulfill both statements at the same time. OR statements have to be written as two separate pieces. I cannot write x is greater than 3 and x is less than negative 5. There is no number that I can put in here that is both less than negative 5 and greater than 3 at the same time. It's impossible. So this is an OR statement because the solutions are separate pieces. Okay? So that's it. We'll talk about it more in class.